Okay, so we're going to do a strong acid, strong base titration today to show you the reaction of a strong acid with a strong base. And we're going to be using, you can see here, sodium hydroxide. I need tin. I need 10 milliliters of sodium hydroxide. So I get my 10 milliliters of sodium hydroxide. And I'm going to put it in my beaker. Now that's not very much, so I'm just going to increase the volume of my base by adding some distilled water. This isn't going to change, it's not going to change the amount of base that's in there. I still have my 10 mils of sodium hydroxide. And then I'm going to add 2 drops of phenolphthalein indicator. This will react and become pink when it's in the presence of a basic solution. Boom. So we have a very basic solution. Now we're going to place this basic solution up here, and I have on the side a pH probe. So I don't know if you guys can see that very well. It's a pH probe. We're going to place the pH probe inside of the basic solution and start getting reading of the pH of this basic solution. Should be around 13 pH. See the base pH listed down here.
Time? Yep.
Okay. So it's listing all of the pHs every second or so at 12.39. So we have a really steady pH. Okay, so we have some acid that's been added to our burette. So you can see here we have a burette, and I don't know if you can tell, but we've got around 25 mils, I'm sorry, about 30 mils of an acid in that burette. Let me set this up so you can see the titration happen. The acid that we're using, that's our acid, hydrochloric acid, the concentration. And we're going to go ahead and turn on our automatic stir. Place the pH probe inside the beaker. And we're going to start collecting data as I allow the acid to drip into the base. As we add our hydrochloric acid to our base, we're going to see a change in pH. So now you can see, I'll get this a little bit closer so you guys can see we're adding some acid to our base in the titration. Set this back over here. Now, we're going to get to a point where our amount of acid equals our amount of base. When that happens, then the solution is going to turn clear. So I'm going to slow down my addition of my acid because I know I'm getting close. Right about to start seeing pH change, because when the acid reacts with the base, it starts to form water and sodium chloride. And when all the base is totally gone, then you'll have no more pink solution, because there won't be any base for the phenolphthalein to react. It's starting to go down. We're getting close to the equivalency point, which is when the amount of base in the beaker is equal to the amount of acid in the beaker. When that happens, all the acid is going to react with all the base, and here it goes.
Oh, okay, so it's steep.
There you go. Now, there's no more base left, and we have an acidic solution at this point, and pH 7 is the equivalency point, is when moles of acid equals moles of base. Now you can see the new pH, because we're just putting acid into the solution, is about 2. Out there. So we have added, we started at 30 mils, and we have added what looks like 9.5 mils, around 9.5, looks like about 9.7, or sorry, 9.3 mils, 9.3 mils of acid, 9.3 mils of acid. The reaction is complete because we don't have any base left.